So we're going to go through simultaneous equations, and we're going to start with just going through what an equation in general is. So for example, here we have an equation that has an x and a y, and they need to satisfy some conditions, and they need to equal 8. So a value of x plus 2 of the value of a y has got to equal 8. So if I said that x was 2, for example, then y would have to equal something that if you multiplied it by 2 and added it to 2 from the x here, it would equal 8. So in this case, 2 plus 6 equals 8. So 2 plus 2 lots of 3, which is 6, equals 8. With simultaneous equations, we have two equations. I'm going to write an example now. Two equations with an x and a y that both have different conditions. So in this case, we have x minus 2y equals 4 and a 2x minus 5y equals 11. And the same values of x in both equations and the same value of y have to make sure that these equations are true. So a value of x here has to be the same value of x here, and it has to take away or the same value of y multiplied by whatever's in front of it in order to equal what it is on the right hand side. I'm going to go through now the steps in order to do this. So step 1, we want to number the equations. So here I'm going to call this one number 1 and this one equation number 2. And now step 2, we want to multiply the equations by the coefficient, which is just the number in front of either the x or the y. So the number in front of the x here is just 1 because it's on its own. So anything with just one of its own is just the coefficient is 1. The coefficient of y is minus 2, which is just here. The coefficient of x on equation 2 is 2, and the coefficient of y in equation 2 is minus 5. So it's just whatever's in front of the x or the y. Coefficient of the x or the y of the opposite equation. So I'll show you what I mean by that and why we're doing this. This is step 2. This here is step 1. I'll show you why we're doing this in step 3. So here we've got equation number 1, which is this equation here, multiplied by the coefficient. We're going to do the coefficient of x here because it's smaller than the minus 5, so we want to make it nice and easy for ourselves. So equation number 1 times by 2. So we're going to have x minus 2y equals 4, all multiplied by 2. So that's going to give us 2x minus 4y equals 8. And that's going to be our new equation that we're going to work with in a second, which I'll show you once I get on to step 3. And similarly with equation number 2, we're going to do equation number 2 multiplied by the coefficient of x on this side, which is just 1. So equation number 2 multiplied by 1, which is just going to give us the same thing because anything multiplied by itself is just what it is. So that's our new equation there. It's important to multiply by the coefficients of the same letters. So if you're multiplying equation number 1 by the coefficient of x of equation number 2, you must also multiply equation number 2 by the same the coefficient of x again. You can't switch between x and y. So we'll write that here. Keep the same letter coefficients. So step 3 is why step 1 starts to make sense. So we subtract the new equations. Here, so we're going to have 2x minus 4y equals 8, take away 2x minus 5y equals 11. So we're going to see first of all that the 2x take away 2x is going to be 0, and that's going to be the same thing each time if you've got the same coefficients. That's why you multiply them by each other. So you've essentially got the coefficients of the x's on both equations to be the same, so that you can take them away from each other and make them go to 0. So we're going to have minus 4y minus 5y, which is just going to get us y, because a minus and a minus makes plus. So you've got minus 4y plus 5y, which gets us 1, which is y. And then we have 8 minus 11, which is minus 3. So step number 4 is to find the value of x or y. And in this case, there's nothing else we need to do because we have a y equals minus 3. In some cases, it might be that you have 2y equals minus 3 or 3y equals minus 3. And in that case, you would have to divide the whole thing by whatever was in front of the y in order to get the y by itself. That's step 4 there. And then step 5 is to substitute the y or the x, whichever letter you've got, into equation 1 or equation 2. So here we will substitute into equation 1. So we now have that y equals minus 3. So we're going to have x minus 2y equals 4, but we know that y equals minus 3. So x minus 2 times minus 3 equals 4. So that means we have x minus 6 equals 4. So then we have x plus 6, because a minus and a minus makes plus, equals 4. So then if we take the minus 6 across to the other side, we take away it because it's got a plus here. So to take it to the other side, we do the opposite. Then we have x equals minus 2. That's 4 minus 6. So now we have a value of y and a value of x. So we have x equals minus 2 and x equals minus 3. And the final step is to check. So we check by substituting the values of x and, oh, I've put x there, and that should be a y. Right again. We have x equals minus 2 and y equals minus 3. And then we substitute the values of x and y into our other equation. So we can see that 2x minus 5y equals 11. Substituting our values that we found for x and y into that, we have 2 times by minus 2 minus 5 times by minus 3 and that is going to get us minus 4 minus minus 15, which is minus 4 plus 15, which equals 11. So that works. And that's your check.